Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1352 for product of last k numbers. Let's read the problem statement. Design an algorithm that accepts a stream of integers and retrieves the product of last k integers from that stream. Okay, let's say if the product stream is something like this: 1, 2, 3, 4, 5. If I just ask you, get me the product of last two elements, that is going to be 5 into 4, 20. Now we have to implement this class, product of numbers class. This class is going to have one constructor, and apart from that, one add function and one get product function. Add function is going to append the integer in the stream, simple. And get product function is going to give me the product of last k integers. This is also looking very simple. Okay, so now let's just implement this class, and there's just some kind of note. Okay, example will look like this: product of number class initialization is taking place, and then add queries. After that we are having multiple add product queries. If I just do this and I simply say that okay, if it is a stream of numbers, and let's also look on the constraints. Num means any number is going to be of range from 0 to 100. This is the number range. And what is k? K is going to be the product of last k numbers. That is going till 10 to the power 4. If I say that let's take a integer list, and let's say if I call it stream, then what is going to be the constructor? Constructor is going to initialize this stream, that's all. And what about add? Add is going to add the number in the stream. If I just add it into the stream, that will look like this: stream dot add num, that's all. And the constructor will look like this: stream is equal to new array list if it is Java. Constant operation. What about the get product? Get product is going to be the product of last k numbers from stream. And what is the time for this? Time is going to be order of k, because we have to iterate k times on the last elements. Let's say from n minus 1 till n minus 1 minus k, or maybe it is going till n minus k. So we just have to iterate over n k elements in this case. So add function is going to take constant time, but this is going to take order of k time. And in the follow-up question they have told me something like this: if it is a follow-up question, why don't you just implement it? Let's say if I just write a for loop, int I equal to n minus 1, which is the last index, I greater than equal to n minus 1 minus k. Let's say let's say we are having 10 elements and we want the product of last two elements. Then the index will go from 0 to 9, and what I require is I have to go to 9 and 8. So in this case, till what value I am going to go? Then 10 minus k, which is this value I definitely have to go. So I should be greater than equal to this value. And what about the other one? I minus, because we are going from bigger value to smaller value. In this case, answer plus equal to stream dot get I, and in the end just return answer. And before that we also have to initialize it. Answer is equal to, see, in this case we want the product is into. And what is the identity property of product? It means just get me any value. Let's say the number is number. If I have to multiply with identity, I'm going to get number itself. So that identity we use to initialize the variable. So answer is going to be 1 in the starting, and multiply every other element and see whether it is working fine or not. Now it will pass. If I just submit it, problem is getting submitted and it only beats 5% of the problems. But in this case, they have also asked us a follow-up question that can you implement both the things in order of 1 time instead of order of k time. So that is the challenging part. So this you can assume as a easy problem in the interview, and the next is going to be a medium follow-up question in the interview. So in this case, the time complexity of add operation is order of 1, but time complexity of get product operation is order of n. These two functions, the interviewer is asking, or the problem is asking us to implement this in order of 1 time. And if I just have to do it in order of 1 time, I need to think of something. Before that, let me ask you a very small problem. We are given 2 functions to implement, and this function we were able to implement in constant time using just data structure.add operation, and this function we were able to do it in the order of k time. Why? Using iteration. But the problem is requesting us to do it in order of 1 time instead. Why order of 1 time? Because there is a possibility that we are going to get product query this function call multiple times. If this function is being called m times, so it will become m into k. But this function is being called m time and the time complexity is 1. Overall it will be order of n. So that's why in some cases where the queries are being called multiple times, we have to take care of the time. Let me show you a similar example that you already must be aware of it. And I have given you an array 1, 2, 3, 4, 5. In this array, I am also giving you a query. Query is ij. Let's say 2, 3. What are these two values? These are the indices 0, 1, 2, 3, 4. And you have to return me the sum of all the values from I to j and the value of k. This value you have to return. This is nothing, just sum of all the values from I to j. I is 2, j is 3. 2 to 3. It means sum of all of these values. Some of these values are 3 plus 4, which is 7. In this case, I am taking order of k time. Why? Because I am doing one iteration. So for every query, I am taking order of k time. If let's say I am having 5 million, then in this case, my time is going to be this bigger value into k. But if I am able to solve this query in order of 1 time, if there is a possibility of getting in too many number of queries, then in this case try to keep this minimized, because on this number of queries we don't have any control. So in this case, how do we optimize it? To optimize these kind of operation, what we have to do is we have to do some kind of pre-processing, and in this case that pre-processing is called prefix. Why? Because in this array, this is index I and this is index j. I want to get the sum of these values. If I already know the sum of this, which means 0 to j, and the sum of this I minus 1 from 0, then I can easily get this value. How do I get this value? Let's say this is a and this is b. This value will definitely be a minus b. It means prefix of j minus prefix of I minus 1, because I is also included in the query. So this is my answer for any query, and this answer I can get in order of 1 time if this prefix array is already prepared. And how much time does it take to prepare this prefix array? prefix array is nothing, just the sum of all the elements. So in this case, if this is the array, what is going to be prefix array? Sum of all the elements till this, which is 1. Sum of all the elements 1, 3 and 3, 3, 6, 10, 15. This is in the case where plus operation is required. But in our problem statement is something else. They are requiring product of last k element. Say you are given an array and they are going to give us k, and from k till the last index, which is n minus 1, I need to get the product of these values. If I know the product of all of these values, right, and then product of these many values, so can I find the product of these values? So let's say this is A and this is B. This is something, let's say X, we have to find out. So A is a product of all the elements, B is the product of these many elements on the left side, and X is the product of element which we require. In this case, B into X will definitely be equal to A, and X is equal to A divided by B. It means product of all the elements. It means product of all the elements till k minus 1. K minus 1, not k minus 1. All the elements apart from rightmost k element. Rightmost k element, these are n minus k elements. Okay, so this is something we have to do. We have to utilize the pre-processing of prefix. Prefix, this is not sum, this is multiplication. So if we have prefix multiplication, yeah, I will definitely get the answer. In this case, we just have to check for one thing about the corner cases, that we will just have a look. Now we will try to improve the time complexity of this get product function from an order of n to order of 1. See, instead of stream, we have decided to go with prefix array. Let me rename it to prefix. So whenever we are getting the initializing the array, we have to initialize it, and after that we have to add this value in this function, but we have to add something like this, num into prefix of n minus 1. What is n minus 1 here? Prefix dot size. Prefix dot size minus 1. This is one case. And what about the other case when num is the first element? In that case, I am going to add num only. So these are the two cases that I need to handle. If, how do I get to know that it is the first element? By checking the size of the prefix. If the size is 0, it means that this is the first element that I'm inserting. Otherwise, this is the case. Okay, so this is fine. And now what else? Get product. For the get product, we already got the idea that it is going to be equal to prefix of last element, which is n minus 1, divided by prefix of element which is before, which is the maximum element which is before the k windows. So let me tell you with the help of example. This is the example. Let's say example is something like this. 4 elements are there. If I just prepare the prefix array 1 and then 2 into 1, which is 2, 3 into this 2 is 6, and 4 into this 6 is 24. And in this case, if the value of k is 2, then what is the value? What I have to do is divide 24 by 2. Then I'm going to get the answer. Divide 24 by 2. What is 24? 24 is n minus 1. And what is 2? N minus 1 minus 2 minus k. It means n minus 1 minus k. So prefix of n minus 1 minus k. What is n here? N is the size of prefix array. Got it. So in this case, this is going to be my answer. Simply just return the answer. Now our problem is in a very good shape. we have prefix array and we are initializing prefix array and we are getting the answer from the prefix array, and this is order of 1 now. I am removing order of n. But here there's one challenge. What is that challenge? Because in the input constraint I saw that it is going to be from 0 to 100. If it is 0 to 100, let's say the third element is 0. If the third element is 0, what is the element? What is the product of last two element? 0. Last three element? 0. Last one element, that is 4. Last four element, 0. So we need to handle that 0 case separately. And how we are going to do that? We can do that by resetting the prefix array. You will understand it how I'm getting the answer. Let me just do it. If value is equal to 0, if the value is equal to 0, just reset it. How do we reset it? Just line number 9, do this thing, and here it is coming as else. If nums is equal to 0, then reset it. Otherwise, size is 0, it is the first element, just add it. Otherwise, just add whatever the way we prepare our prefix array. This is multiplication. This is looking good, and here in this case we also have to check for something else, like let's say prefix of n-1. Let's say n-1 can be less than k in this case, because we are resetting the value 0. We have reset the value, and now the array, prefix array, will look like this. Prefix value initially became 1, 2, and then at 0 I am just clearing it out, and then at 4 I am just inserting 4. Now in this case, if I just have to check this, I am damn sure that it is falling into previous element which is having 0 at the end. So definitely it is going to have 0, and if k is greater than the current size of the prefix, then definitely we have encountered 0. So this case is something like this. If value of k is greater than n, if the value of k is greater than n, value of k is 2 and the n is 1, n is the size of this prefix, in that case directly return 0. If it is falling into this case, then return 0. Will it be working fine? So here we have checked that k should be greater than n, then answer is 0. What about this k is n? If I just tell you in this case value of k is n, then what should be the answer? Answer should be 4. And in this case, what should be this value? We are dividing 4 with what? We are not dividing with 4 with anything. So why not we just handle that case separately? If k is equal to n, in this case we have to return prefix dot get n-1. Now test again. This question requires a lot of edge handling. Now it is working fine, and this is the prefix array. Initialize it, and just initializing the prefix array, that's all. We are just handling this negative 0 case separately, special case. Otherwise we are applying this logic. Use pre-processing. This is not the pre-processing. Use prefix array. Let me submit it. It is submitted successfully, and now this time it is 91.34%, beating other solutions. And what about the previous one? Previous one took these many milliseconds, and now this is taking only 15 milliseconds. It's a huge improvement. I hope you have understood this approach. If you have any doubt, you can ask in the comment section below. Thank you guys. Bye bye.